Greeting, my name is Jarina Laki Parmasivam, and thank you to Prof. Maria T.S. Dr. Maria Binti Awang for giving us this opportunity to present this project. So, on behalf of my group and team, I'll be kicking off our presentation on evaluation of fire safety legislation standard compliance. Our target for this diagnostic assessment is the Student Residential College building, specifically College Kediaman Campus, Pagoh Block A10. This facility falls under the jurisdiction of Koperasi UTHM Berhad, and our team evaluated its operational readiness using the legal frameworks of UBBL 1984, Act 341, as well as Malaysian Standard and NFPA standards. Moving to our objective, our main goal was to assess the building's design compliance against primary Malaysian legislation, namely the UBBL 1984 and the Fire Service Act 341. We also evaluated both the active and passive protection system of fire system, benchmarking them against the technical requirement of Malaysian Standard, National Fire Protection Association codes. Beyond just checking boxes, we aim to investigate any existing system defects, formulate technical justification for those flaws, and ultimately provide the management with a prioritized roadmap for safety enhancement. Let's look at the building's background of Block A10 and the physical characteristic. So Block A10 is a 5-story reinforced concrete structure serving as male residential student accommodation. It has a total of capacity of 480 persons, which includes the ground floor lobby area. The layout consists of 8 house units per floor with 4 rooms per unit, resulting in a density of 12 persons per unit. This facility is actively managed by Koperasi UTHM Berhad Muar Pagoh branch. Because this is a residential building, the occupancy type brings specific fire risk implementation, which we've mapped out on this evacuation timeline. Since students sleep here, we are dealing with a nighttime residential scenario that inherently involves delayed reaction to a fire hazard. Sleeping residents require highly stringent automated early warning system to overcome this delay response. Furthermore, nighttime evacuation carry the risk of disorientation due to limited visibility, cognitive impairment upon waking up. Finally, there is a significant electrical hazard present. Our interviews indicate that students often bring high-powered personal electrical appliances into their rooms, which introduce a severe risk of electrical overload at the distribution board.
Okay, next, my name is Amir Hakim bin Muhammad Razwan, DN240089. For this slide, I will present the inventory of active fire protection equipment that have been identified in the Student Residential College building. The equipment is divided into 2 main categories, which are detection and warning and suppression. Under detection and warning, the building is equipped with 245 heat detector, 10 alarm bells, 10 manual break glass units, and 1 main fire alarm panel with a sub-panel. These components are important because they provide early warning to occupants during a fire emergency. The heat detector are used to detect abnormal temperature rise, while the alarm bells and break glass units help alert the occupants and activate the emergency response. For fire suppression, the building is provided with 10 ABC dry powder fire extinguisher, 10 hose reel, and 1 external fire hydrant. These are used to support initial fire response before the arrival of bomber. Based on the inventory, the physical provision of active fire protection equipment appears to be sufficient for the building. However, it is important to note that presence of equipment alone does not confirm full performance. The actual functionalities such as alarm audibility, detector operation, hose reel, water pressure and extinguisher condition must still be verified through inspection and maintenance record. Okay, next I will move to the next slide, which shows the Malaysia standards that are relevant to the evaluation of fire safety system and building design. In this project, the main standard considered are Malaysia 1745, Malaysia 1183 and Malaysia 983. Malaysia 1745 is related to fire detection and alarm system. It provides guidance on aspects such as detector, arrangement, alarm zoning, audibility, and backup power. This standard is relevant because the building is equipped with heat detector, alarm bells, manual brake glass units, and fire alarm panel. Malaysia Standard 1183 focus on means of escape and evacuation provision, especially for occupants who may require assistance, such as persons with disabilities. This is important for a student residential building because evacuation planning should consider all categories of occupants, not only normal user. Next, Malaysia Standard 983. It is related to fire precaution in building design and construction. It supports the evaluation of general fire safety planning, compartmentation, occupant protection, and overall fire safety management. Overall, these Malaysian standards are used as technical reference to support the legal requirement under UBBL 1984 and the Fire Service Act 1988. They help ensure that the building is not only legally acceptable but also practical and safe for occupants during emergencies. Okay, next I will move to the next slide, which present the selected NFPA standard that can be used as a global benchmark for a comparison. Although NFPA standards are not the main legal requirement in Malaysia, they are useful as supporting reference because they provide internationally recognized fire safety practice. NFPA 72 focus on fire alarm and signaling system. It covers important aspects such as alarm audibility, system reliability, and backup power. This is relevant to the building because it contains fire alarm panels, alarm bells, heat detector, and manual brake glass units. NFPA 10. It is related to portable fire extinguisher. It provides guidance on extinguisher selection, location, inspection, and maintenance. This is useful when evaluating whether the ABC dry powder extinguisher are placed appropriately and maintained properly. NFPA 40 covers the pipe and hose system, which is relevant to the hose reels provided in the building. It highlights the importance of water flow, pressure, and system readiness. Okay, and last one, NFPA 101. Also known as the Life Safety Codes, provide guidance on means of escape, emergency lighting, exit roads, and occupant notification. Therefore, it supports the evaluation of occupant safety during evacuation. In this project, NFPA standards are used only as a supporting benchmark, while the main compliance assessment remain based on Malaysia legislation and standards. Okay, next this slide will summarize the main Malaysian fire safety legislative framework used in this project. The two main legal references are the Uniform Building Bylaw 1984, also known as UBBL 1984, and the Fire Service Act 1988, also known as Act 341. UBBL 1984 is important because it provides minimum design requirement for buildings. It covers aspects such as means of escapes, exits, fire resistance, staircase, corridors, and maximum travel distance. In this project, UBBL is used to evaluate whether the building design provides safe evacuation routes for occupants. The Fire Service Act 1988 focused more on fire safety enforcement, maintenance, inspections, and the role of bomber. It supports the operational side of fire safety such as fire certificate renewal, maintenance responsibility, and ensuring that fire safety system remain functionally throughout the building operations. In simple terms, UBBL 1984 mainly guides the design and construction stage, while the Service Act 1988 supports the operation and maintenance stage. Both are important because fire safety compliance does not depend only on the building layout, but also on how the fire safety system are inspected, maintained, and managed. Therefore, these two legal reference from the main foundation for evaluating the fire safety compliance of the students' residential college building.
Hi, my name is Clinton Nick James, and I will present for this slide. So, for this slide, we evaluated the means of escape and exit routes that provided in Block A10. So, based on the floor plan and site observation, the building has two open staircases located at opposite ends of the block. So, this arrangement provides a good exit redundancy because occupants are not dependent on only one escape route. So, if one staircase is affected by fire or smoke or obstruction, occupants may use the staircase on the opposite side. However, the main weakness is that both staircases are directly connected to the common corridor and are not enclosed by fire-resistant walls or separated by fire-rated door. This means smoke from the corridor may enter the staircase area and reduce the effectiveness of both escape routes. So, although two alternative exits are provided, their performance still depends on keeping the corridor free from smoke or obstruction. Overall, the exit arrangement is useful, but the staircase protection requires further technical verification and improvement. Next, I will explain for this slide about emergency assembly points and evacuation plans. So here got three steps. So I will explain about the step one, which is visual evacuation aids. So first, the emergency routes plans are and directional arrows are displayed on the residential floors. So these visual aids can help occupants to identify the correct routes towards the staircases and also to reduce confusion during an emergency, especially at night when students may be sleeping. So for the second step about discharge level, so occupants from the upper floors are directed to descend through the two staircases to level 1 before proceeding outside the building. So basically, level 1 functions as the main discharge level that connecting the internal escape route to the external safe area. So for the second step about safe assembly zone, so for block A10, residents are directed to the designated assembly point that located at the parking area between A6 and block A10. So this location allows the ERT team, or we call it emergency response team, and building management to conduct head counts and identify whether any occupants are missing. Overall, the evacuation plans is clearly arranged, but it is effectiveness still depends on clear signage, unobstructed routes, occupant awareness, and regular fire drills. For this slide, I will summarize the technical evaluation of active fire protection performance in block attends. So, the main strength is the extensive detection coverage provided by 245 heat detectors. So, these detectors are distributed throughout residential rooms and also common areas that are connected to a zone alarm system. The zoning arrangement allows the control panel to identify which area that affected and also active the alarm within the relevant blocks. So there are several performance aspects still require verification. Although alarm bells and hose reels are physically available, alarm audibility inside bedrooms and hose reel water pressure, especially on the upper floors, have not been confirmed through a functional testing. Another concern is that there's no CO2 fire extinguisher was identified in Block A10. Basically, we do the side inspection. So we saw that there is CO2 legend in the panel, but we can't identify which area that the CO2 was placed. Although the MBC dry powder extinguisher are provided, the suitability of CO2 extinguisher should be reviewed for electrical risk areas such as distribution board, rooms, or ICT related spaces. Therefore, the active fire protection system is generally provided, but further testing and targeted improvements are needed to confirm its operational reliability during an actual fire emergency. Next, I will explain about this slide about fire safety management, inspection, and maintenance. So, based on the interview that we do, annual fire safety inspections are conducted and maintenance records are systematically kept. These records include equipment faults, repairs, and system maintenance. The fire alarm control panel also helps the management to identify activated or malfunctioning devices. And also, fire certificate renewal forms part of the formal fire safety compliance framework. Although the current certificate status should be verified, the main operational gap is that annual inspection alone may be not sufficient for a student residential building that is occupied every day. Fire, sa- fire safety conditions can change between formal inspections. Corridors may become blocked, exit sign may be damaged, and equipment may be misused, and new electrical risks may be introduced. Therefore, management should introduce more frequent internal monitoring, such as a weekly or monthly inspection. So, these checks should focus on escape route, obstruction, alarm condition, extinguisher accessibility, exit signage, service penetration defects, and student electrical appliance risk. Overall, the current management system is systematic, but it should be strengthened through more frequent internal checks to ensure continuous fire safety readiness throughout the year.
Let's review our non-comprehensive summary. Our risk matrix highlight 5 critical vulnerabilities. Most urgent are the immediate risk, unprotected open staircase that can act as channels during a fire, and unsafe service penetration by placing concrete resistance. Moving down, moderate risk include irrigation, internal compartmentation, and over-reliance on ABC public extinguisher and frequent road obstruction. Addressing this immediate hazard is our top priority. Next, look at our emergency response team and drill effectiveness. Our ERT successfully integrates student, lecturer, and staff, demonstrated by our recent realistic midnight simulation. However, we have identified a critical timing flow. These are currently conducted in week 40 to properly protect new unfamiliar residents when they are most vulnerable. We must systematically shift this simulation to week 1 of the academic semester. Based on our inspection, we identified two weaknesses in the building passive fire protection. First, the main door do not have visible fire rate certification label or self-closing mechanism, making it difficult to verify the fire system. Second, there are unsealed gaps around service penetration, such as PVC pipes through wall and floor. These gaps can allow smoke and fire to spread rapidly. Therefore, proper fire rate door and fire stopping system should be installed to improve safety. Also, there are some weaknesses. The building has several important strengths. Heat detector provide early fire detection throughout the building. 12 staircase offer alternative evacuation during emergency. Emergency exit sign and evacuation plan help occupants escape safely. In addition, regular maintenance and fire drill simulation show that the building management is committed to maintaining a safe environment. Overall, the building has a solid fire safety foundation but still requires improvement in passive fire protection.
For these slides, I will explain the technical justifications under the title Anatomy of an Escape Failure. The main point of this slide is the presence versus performance gap. This means that even though Block A10 has a good active fire protection systems such as heat detectors, alarm bells, break glass units, and fire extinguisher and hose reels, the overall safety can still be affected if the passive fire protection and escape routes design are weak. The first stage is the source event. A fire may start inside a student bedroom, for example, due to electrical overload from high power appliance. In these situations, the heat detector can activate when the temperature increases, but heat detector may take more time to respond compared to smoke detections. This is important because Block A10 is a sleeping occupancy, whereas students may be asleep and slow to react. The second stage is the unit being compromised. If the smoke starts to spread inside the residential units, the occupants may have limited time to react. Since the units contain several bedrooms and depends mainly on the shared internal space and main exits, smoke movement can quickly affect other occupants within the same unit. And the third stage is barrier failure. This refers to weakness in passive fire protections. If the main unit door, wall opening, or service penetration are not properly sealed or fire stopped, smoke can move into the common corridor. This is dangerous because the corridor is part of the evacuation routes. And the final stage is the escape route being lost. Although Block A10 has 2 staircases, the staircases are open and directly connect to the corridor. If smoke enters the corridor, it can also enter the staircase area. This can reduce visibility, increase panic, and make evacuations from the upper floor more difficult. Therefore, the key message from this slide is that fire protection cannot depend only on the presence of equipment. The active system may detect and alert, but the passive system must contain smoke, protect the escape route, and give occupant enough time to evacuate. In conclusion, Block A10 has a good basic fire safety foundation, but improvements are still needed. These include reviewing staircase, smoke protections, improved compartmentation, sealing service penetration, testing the alarm system, controlling electrical appliance, and strengthening fire safety briefing for students. For these slides, I will explain the key recommendations for safety enhancement in Block A10. The recommendations are divided into 4 phases, starting from immediate operational action until long-term structural improvements. This phase approach is proposed so that the management can improve fire safety step by step based on priority, cost, and urgency. Phase 1 is immediate operational improvement. The first action is ensure all corridors, staircases, and escape routes are clear from any obstructions. Even though the road was observed to be clear during the site inspections, regularly monitoring is still important because temporary obstruction may occur during daily student use. The management should also update and verify all formal inspection records, including maintenance reports, alarm testing records, and safety equipment checks. For phase 2 is short-term testing and training. The fire alarm system should be tested to confirm that the alarm can be heard clearly inside student rooms, especially at night. Hostile water pressure should also be tested, particularly at the upper floor because Block A10 is a 5-story building. In addition, 5 fire drills should be shifted to week 1 or the early semester so that new residents understand the escape routes, assembly point, and emergency procedures from the beginning. The digital electrical appliance registration should also be enforced to control high-power appliances such as air fryer and electrical kettles. For Phase 3 is medium-term target upgrades. CO2 extinguishers should be installed in DB rooms, electrical rooms, and ICT relay space because they are more suitable for electrical fires compared to dry powder extinguishers. Fire stopping should also be applied to PVC pipe penetrations and other surface openings to prevent smoke and fire from spreading through hidden gaps. This will strengthen passive fire protection in the building. For Phase 4 is long-term structural improvement. The open staircase should be reviewed and enclosed with fire-resistant walls and doors where practical and approved by the relevant authority. This is important because staircases are the main vertical escape route for occupants from the upper floor. Internal compartmentation in residential units should also be upgraded to delay smoke spread between rooms and provide occupants with more time to evacuate. Overall, this recommendation shows that fire safety improvement should not be done randomly. It should begin with low-cost immediate actions, followed by testing and training and target upgrades, and finally, structural improvement. This will help Block A10 move from basic fire safety compliance toward a more reliable and safer fire safety systems. For the final slides, this marks the completion of our diagnostics evaluation for Block A10. Overall, our evaluation shows that Block A10 has a reasonable basic fire safety systems, including active fire protections, emergency roads planning, assembly points, maintenance record, and EART involvements. However, several improvements are still required to strengthen smoke protections, compartmentations, alarm reliability, electrical fire safety, and occupant preparedness. This main message from this study is that fire safety should not only depend on the presence of equipment, it must perform effectively and as one complete system during an actual emergency. With that, we would like to thank Koperasi UTHM Berhad, the University Management, our lecturer, and everyone involved for their cooperation and support throughout these evaluations. Thank you so much.